So let's see if we can find a fourth degree polynomial that satisfies these given conditions. Now remember, our polynomial function, it must have real coefficients. That was given in the problem statement. Well, what do we know about our function that we're looking for? It must be fourth degree, and we're given that 1 is a 0 of multiplicity 2. That means that x minus 1 is a factor twice. Okay? Now let's put a leading coefficient of a out in front. Okay? And what else do we know? We know that 2 minus I is a 0. Let's write that right here. 2 minus I is a 0. All right. Well, by the conjugate pairs theorem, because we have real coefficients, that was in the problem statement, if a complex number 2 minus I is a 0, means that its conjugate, 2 plus I, is also a 0. All right. Well, because 2 minus I is a 0, we know that x minus 2 minus I must be a factor of our polynomial. Similarly, because 2 plus I is a 0, that means that x minus 2 plus I is a factor. And notice my use of parentheses. Now what we're going to do, we're going to multiply all this together, and that should be our fourth degree polynomial. Let's just make sure we've got a fourth degree. I've got an x squared times another x term will give me an x cubed, and times another one will give me an x to the fourth. So there's my fourth degree polynomial in factored form. Now we want to multiply this out. Let's take our time and go slow. Let's leave our leading coefficient out in front. X minus 1 squared is x squared minus 2x plus 1. Okay. Now before I multiply the second two factors together, let's distribute the negative sign so it looks a little nicer. So x minus 2 plus I for our first factor here. We'll do the same thing with the last factor, writing x minus 2 minus I. Okay. Now let's go ahead and multiply the last two factors together. All right, well, I'll leave a little room over here because it's going to be pretty lengthy, I think. So let's just multiply the last two factors together. X times x is x squared. X times negative 2 is negative 2x. And x times negative I is negative xi. Again, go very slow through this whole process. It's very easy to make a mistake. Now we'll take the negative 2 and distribute it through the final factor. That gives us negative 2x plus 4 plus 2i. And finally, we'll take the I and we will multiply that through the final factor. I'll write it down here. This gives us plus xi minus 2i and finally minus I squared. And let's simplify this. Combining like terms, we get x squared, let's cross them out as we go, minus 4x, okay, negative xi and positive xi, those cancel, positive 2i and negative 2i, those cancel, and we have plus 4 and minus I squared. All right, well remember what I squared was. The definition of I squared was I squared is equal to negative 1. So we have a negative times a negative 1, which is a positive 1. And so we can simplify to x squared minus 4x plus 5. So that's what we get when we multiply the last two factors together. So let's get a clean sheet of paper and we'll clean this up a little bit. What is left is to multiply our two quadratic factors together, and then we will be done. So let's do that. Again, I'll leave the a, our leading coefficient, out in front. and let's multiply. Let's take x squared, we'll multiply it through first. That gives us x to the 4th power minus 4x to the 3rd power plus 5x squared. Now we'll take the negative 2x and we'll multiply that through the last factor, giving us negative 2x to the 3rd power plus 8x squared minus 10x. And finally, we'll take the 1, multiply it through, giving us plus x squared minus 4x plus 5. And let's simplify, collecting our like terms. We have our leading coefficient of a. Now let's look at our highest power. We have an x to the 4th term, so we'll write that. Now I have a negative 4x cubed minus 2x cubed. That's negative 6x cubed. Looking at our x squared terms, we have 5x squared plus 8x squared. That's 13x squared plus 1x squared is plus 14x squared. Now looking at our x terms, we have negative 10x minus 4x is minus 14x and plus 5, our constant. Now the problem said to find a polynomial that satisfies the given conditions. Well, this one certainly does. But what about a? Well, because it just said find any polynomial, find a polynomial that satisfies it, how about we just let a equal 1 in this case? You could let a be anything. Any choice of a will satisfy the given conditions. But if I just let a equal 1, I get the polynomial x to the 4th minus 6x cubed plus 14x squared minus 14x plus 5.